Good morning, my YouTube viewers. It is Crystal here, and I'm just here because I wanted to do a decision tree classifier with the JAX library. And so we're going to be using sklearn's wine dataset. One thing that I will say is that I tried this classifier on a Kaggle dataset for a Kaggle competition, and it didn't turn out very well. So I think that this Kaggle competition was intentionally made difficult to get a good score. So the decision tree classifier with JAX, it's a good classifier, but it's not always the best algorithm to use. So even though it worked on sklearn's wine dataset, it didn't work very well on Kaggle's horse health dataset. So since it did work well with the wine dataset, I'm going to go ahead and do a code review on the wine dataset. So I've created this program in Google Colab, which is a free online Jupyter notebook hosted by Google. And JAX is a library that was developed by Google in 2018, but you don't really see a lot of it on Kaggle. I mean, I just recently heard of it, even though JAX has been out on the market for 5 years. I just recently heard about it, and the reason why is because JAX doesn't have algorithms like machine learning algorithms. You have to create the machine learning algorithms yourself. And since you have to create the machine learning algorithms yourself, it's a little bit more complex to work with than sklearn or Keras TensorFlow. But I want to learn JAX, and so that's what I'm doing. So after we created our program in Google Colab, which I would like to say, by the way, doesn't have a very good undo function, so you have to be very careful not to accidentally overwrite or delete code, otherwise you might not get it back. So after we have created that Jupyter notebook, the first thing that you want to do is you want to import your libraries. And so for this particular program, we're just going to import JAX. We're going to import jax.numpy as JNP. We're going to, from sklearn, import datasets, and from sklearn.model-selection, input train test split. Now, I could have imported matplotlib for visualization purposes and Seaborn for visualization purposes as well, but I didn't do it on this occasion. But I have done it. I did it on the Kaggle competition question, but since it didn't do very well on that competition question, I'm not going to bring that competition question up. What I will say is when you're working on a data set that you need to use several different algorithms and select the algorithm that works best. So obviously decision tree classifier didn't work well on this algorithm that I was working on, but it did work well on wine, which is why I'm doing it with the wine data set. So after we have imported our libraries, what you want to do is you just want to set the seed as key equals jax.random prng key 42. So what that does is when you run an algorithm up, it'll run, if you run it up on the key, then it'll run the same all the time. So we're going to load the data set, and we're going to be using sklearn's load wine data set. Data equals load wine, x equals data.data, y equals data.target. We print x shape, it's 178 by 13. And we print jnp.unique y, and so that tells you how many unique values you have in y. And you've got 3 unique values in y, being 0, 1, and 2. So now we're going to use sklearn's train test split to split the data set up into X train, X test, Y train, Y test. And so you can check the shape of those data sets or data frames as well. And now we start with the decision tree algorithm. First thing we're going to do is we're going to have a class called decision tree node. That's your node. And so it has an init function in it. And the init function initializes the values of self.depth, self.nextDepth, self.left, self.right, self.featureIndex, self.threshold, and self.value. So that is your class for your decision tree node. So now what we're going to do is we're going to define the functions that are actually going to be used to create the decision tree. The first function we have is define a function to split the data based on a tree and threshold. So we split the data with that function. The next thing we do is we have a function to calculate the Gini impurity. So that returns your Gini impurity. The next thing we do is we have a function to define the best split. So we have the function to define the best split. And then we have a function to build a decision tree. And so we build our decision tree. And then after that, those are the last functions that we have for the decision tree. So now what you want to do is you want to predict on your decision tree. So we have a function to make a prediction. And what I will say is I'm going to include in this video a link to a Medium article that I wrote that explains the decision tree classifier. So if you read that article, it'll go into detail about what each line of code in the decision tree classifier is. So now after we have developed our classes and our functions, we're going to build the decision tree. So the max depth is 3. You determine what the max depth is going to be. Decision tree equals build decision tree, X train, Y train, and then max depth are the inputs. Now what we're going to do is make the prediction. So you're going to make a prediction on each row of the data frame. So ypred equals predict tree, brackets decision tree, comma x, for x and x test. So what that does is that makes a prediction on each row of data. Ypred equals jnp.array ypred, and then you've got ypred. Now what we're going to do is we're going to calculate the accuracy, and so this is a function that I use to calculate the accuracy, and it has a 91% accuracy. Now what we're going to do is we're going to compare sklearn to the decision tree classifier made by Scratch, and when we do it, we say from sklearn import tree, model equals tree dot decision tree classifier, max depth equals 3, fit x train y train, ypred equals model dot predict x test, and then we calculate the accuracy, and you got a 95.5% accuracy. So you can see that sklearn's decision tree classifier worked better than the decision tree classifier that we made from scratch. And then you have a little tree here. So in this particular situation, sklearn worked better, but you've got to understand about sklearn is they've got lots of people working on that library to improve the algorithms on that library. So I don't have the code for sklearn's decision tree classifier, so I can't really tell you exactly what they did, but obviously they did something. So I'm going to go ahead and conclude this video because we've talked about a decision tree classifier in JAX. And what I will do is I will give you the link to the Medium publication article that I have written that will explain all of the code to you. So thank you so much for watching my video. Thank you to my subscribers for subscribing to my channel. If you like my video, please like, subscribe, and share. If you would like to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you again for watching my video. I look forward to making more code reviews for you in the future.